And in this video, we're going to be talking about exponents. Specifically, we're going to be talking about what exponents and their bases are. So that's just our basic definition. And then we're going to be talking about the product rule of exponents, which is really a really easy rule in algebra to understand. It's probably one of the easiest. And I'm going to do my best to not only share with you what the product rule is, but explain a little bit about why it works. So let's get started. First thing we're going to do today is talk about exponents and bases. This is something you've probably learned about before. An exponent is a tiny superscript number that we put after the number it refers to, or after its base. And what it indicates, an exponent indicates the number of times a number multiplies itself. So let's go ahead and take a look at an exponent. Here we have the exponent 4, and that's telling us that this 2 is multiplying itself 4 times. So 2 to the 4th means 2 times 2 times 2 times 2. Now I'm going to go ahead and figure that out without a calculator here. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so when I do that out in my head, 2 times 2 times 2 times 2, 2 to the 4th evaluates to the same thing as 16. Now, the little number 4 is an exponent. What do we call the 2? The 2 is known as the base. It's the number that's being multiplied repeatedly by an exponent. So in this case, the exponent is 4 and the base is 2. Sometimes we're going to have values that look like this in algebra. Just some number that might even represent a range of numbers, okay? A range of numbers that are going to be multiplied by itself a certain number of times. In this case, this exponent indicates that the variable x is multiplying itself 2 times. I still have an exponent, I still have a base, but it's important to realize that sometimes the exponents or the bases in algebra are going to be variables. Remember, 2 is a constant, so 2 to the 4th, I know the exact value that's going to evaluate to, 16. X squared, though, I don't know what that's going to evaluate to because I don't know what the value of x is. In fact, x probably can take on a whole range of different values. So all I know is that whatever x is, it's multiplying by itself 2 times. One x multiplied by another x. All right, so let's take a look at how we expand these out. 2 to the 4th actually becomes 2 times 2 times 2 times 2. These are equivalent notations. 2 to the 4th means 2 times itself 4 times. 2 times 2 times 2 times 2. 2 to the 6th, 2 times itself 6 times. 2 times 2 times 2 times 2 times 2 times 2. Okay, so this is what exponents do. They multiply numbers by themselves. And again, exponents and bases can be variables, so be on the lookout for that. Now, what about the product rule of exponents that I mentioned at the beginning of the lesson? Well, the product rule of exponents is one that looks complicated, but it's actually not too bad. If m and n, notice that m and n in my little notation down here are exponents. If m and n are real number exponents, and the base x is not equal to 0, there's an important reason for that we're going to get to later, but for right now, we're not going to worry about why that is. Okay, we're just going to say that we have a non-zero base, and my exponents are real numbers. Then what I can do is if I have x to the m times x to the n, in other words, if I have the same base, doesn't matter if it's 2 to the 4th, 2 to the 6th, if it's x, if it's a variable, if I have the same base raised to different exponents, I can simplify that by just taking my base and writing it to the sum of the exponents. You see what's going on there? X to the m times x to the n equals the same thing as x to the m plus n, if I added those two exponents together. We're going to practice with this because this is not an intuitive thing that just automatically makes sense. And we're going to practice with it starting with 2 to the 4th and 2 to the 6th in such a way that we can make sense of what it means. So let's go ahead and take a look at that. 2 to the 4th times 2 to the 6th. I'm going to take these two numbers and multiply them together. By the way, we already evaluated 2 to the 4th as 16. 2 to the 6th would be that hard to evaluate because we're just going to take 16 times 2 is 32, times 2 is 64. So 2 to the 6th would be 64. Now what if I had 2 to the 4th times 2 to the 6th? Now if you're intuitive, you probably realize that 2 to the 4th is 16, 2 to the 6th is 64. I could just multiply 16 times 64. That would give me the right answer. We're going to do this a little bit differently though. I'm going to write out the expanded form showing all the multiplications. So 2 to the 4th is 2 times 2 times 2 times 2. 2 to the 6th is 2 times 2 times 2 times 2 times 2 times 2. Okay, how many times am I actually multiplying 2 here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm actually multiplying 2 times itself 10 times. Keep in mind that all an exponent is how many times you're multiplying the base by itself. And if I multiply it by the same base with a different exponent, all I'm doing is I'm multiplying that same base by itself even more. So what is this going to become? Well, I could rewrite it as 2 to the 4 plus 6. 2 to the 4 plus 6. Because I'm multiplying 2 times itself 4 times and then 6 more times. So a total of 4 plus 6 times. Or 2 to the 10th. And really the product rule of exponents is just these last two parts here. 2 to the 4 plus 6 equals 2 to the 10th. So all I'm doing is I'm adding together the exponents because I'm multiplying the same bases by different exponents. Let's take a look at another example, but this time we're going to use a variable instead. What's x squared times x to the third? Can I even simplify this? Well, I'm not going to be able to simplify it to a specific number. And by the way, if I wanted to, I could punch 2 to the 10th into a calculator and figure out what it is. Here, I have a calculator with me right now, so let me just do that really quickly. I'm just going to do, in my scientific calculator, 2 to the 10th. And I get 1,024. Okay? Also, I would have got 1,024 if I multiplied 16 times 64, I'll bet. Now, I'm just going to leave it as 2 to the 10th. Actually, a lot of times in our book, it's okay to leave things in this format, unless it's clear that that's not what you're supposed to. So if I was supposed to evaluate 2 to the 10th, obviously I'd have to evaluate that to an actual number. But there's going to be times in our book where really 2 to the 10th is all we'll have to write as an answer to this. All right, now let's move on. The reason I brought that up is because we can't evaluate x squared times x to the third because we have a variable as a base. So we don't know what x actually is, but we can simplify this by simply combining the exponents. Because what is this? This is, and I wrote this backwards, but this is the same thing. Here's my x squared, and here's my x to the third. X times x times x times x times x, okay? And when I do that, I find that I have x to the 2 plus 3. I have these 2 x's plus these 3 x's multiplied by itself that many times. So this simplifies to x to the 5th. All right, let's move up one level of difficulty. What if I have this kind of problem? Here I have x's and y's, different bases. I can't combine different bases with exponents. I can't combine different bases. But what I can do is collect the same bases together. Hey, one other thing here. Notice that my x, that second x, doesn't have an exponent. Anytime a number doesn't have an exponent, there's actually an implied exponent of 1. Okay? So you're never going to see x to the 1 written in a math book, but you should know that x by itself is being multiplied just one time, sort of. It's just x to the 1 and x are the same thing. Okay, so how am I going to combine these together? Well, I'm going to write out my expanded forms of my x's first. X times x times x, and then my expanded form of my y's, times y times y times y times y times y. Okay, now I can't simplify all of this into just one variable because I have 2 different variables, x's and y's. But what I can do is collect my x's together and collect my y's together. Let's do that. I have 2 plus 1 x's and 3 plus 2 y's, so my answer is going to be x to the third, y to the 5th. Notice I'm keeping my 2 different bases separate from each other. I can't combine them, but I did collect all the x's into one term and all the y's into one term, and that's going to be what you're expected to do as well. And then finally, I just want to share with you 3 steps to simplifying any exponent expression. Step 1, you should identify the exponent in the base. Now, here's the step that if you're a well-versed algebra student, you could probably skip. But if you don't get how this works, you should never skip this step, okay? Rewrite as repeated multiplication. You don't have to do this step, But if you're not really getting how exponents work, this is going to help you understand what you're actually doing when you evaluate an exponent. You're multiplying a number by itself the exponent number of times. Okay, that's step 2. And then step 3 is simplify by combining like bases, adding together the number of times you're multiplying. So I'm looking at that last problem, y's. There were 5 y's being multiplied together in my expanded section. So I should end with y to the 5th, or x and x to the 3rd, because there were 3 x's. All right, that's the lesson for today. Next, we're going to move on to the practice.